Hello, everyone, and welcome to the Calian Advanced Technologies Decimator D4 webinar. We much appreciate your attendance today. My name is Jim Shedden, Sales Manager at Calian Advanced Technologies. During this session, you will learn more about the features and capabilities of the Decimator D4. Today's presenter is Peter Waskowick, Director of Satcom Products with Calian Advanced Technologies. Peter has over 25 years of experience with the company, and his career has focused on the development of both hardware and software products, particularly in the satellite test, measurement, and monitoring areas. Peter's team is focused on delivering innovative, high-performance products to customers, including the Decimator D4. He is a professional engineer with an MSc, a Master's of Science degree in electrical engineering. Just a few housekeeping items first. Participants are welcome to send questions throughout the webinar by clicking on the questions button on the left-hand side of your screen. Questions will be answered at the end during a brief Q&A period. If you wish, you may hold your questions until near the end of the presentation in the event we cover and answer the question during the presentation. If for some reason your question wasn't answered at the end of the webinar, or you would like to reach out to us directly, we will have our contact details listed at the end. An email will be sent to you, all who attend today, as well, with a URL to the recorded presentation, providing you the opportunity to view it again at your convenience. Now I'll turn it over to Peter Waskowick, our Director of Satcom Products, to begin the presentation.
Thanks for the introduction, Jim. And special thanks to everybody at the webinar today. I really appreciate you taking some time and spending time with us today to learn more about the Decimator D4 and to discover some of its new features and capabilities. I know everybody's super busy, so the fact that you're spending some time with us today is truly appreciated. Okay, just wanted to let you know a little bit about the format of our webinar today. We'll go through a little bit of a slide deck in terms of some of the features of the Decimator D4 from a very high level, and then I'll flip over to a web browser and we'll look at the Decimator live. We'll do a live demo of some of the features and capabilities there as well, so you can see how it does operate in a live, dynamic sort of format, not just on a slide deck. After all that, then we'll go back to a question and answer session that Jim will host based on any of the questions that you've presented over the course of the webinar. Okay, so let's get to it. Here, it's the Decimator D4. A lot of you people in on the webinar today are people that are previous Decimator users, and you are familiar with our previous Decimator products. Not so surprisingly, the 4 in the D4 stands for the 4th generation of the Decimator product. So there was a D1, D2, and a D3. The D3 was quite popular out in the marketplace, so several of the people in on the call today have a D3 and are familiar with the features. So what I'll mainly focus on here at the beginning is to identify the features that are new or different from the previous generation. So it'll be very easy for you to tell the new capabilities within the D4. Okay, so on the hardware level, we have the similar form factors as in the D3. We have a multi-port form factor, which is probably the most popular way people procure the Decimator D4. And the multi-port comes in both a 4-port variation and an 8-port variation. And you can kind of see this in the bottom right-hand corner of your screen in the slide deck. The hardware is shown there. Like the D3, the 4-port and the 8-port, the units come with an 8 ports by default, and you can turn on the additional 4 ports if necessary with the software license. So all of the units come with the 8 physical ports on them. The one shown in the picture is an 8-port 50 ohm SMA connectors. Also comes in a F-type connector variant for 75 ohm connections in facilities that require those types of signals. You can tell that the look and feel of the unit's a bit different than the D3. We went to a black coloring and powder-coated painted chassis as opposed to the previous aluminum chassis. We think it looks better. Still probably not an art piece that you set on your mantle, just for somebody like myself who really loves the product. But very, very I do like the new look and feel of the device. And we went to a front and back airflow on the unit because what we've been getting some feedback from customers is that most racks inside gateways and teleports now are using the server racks, which have the back to front airflow. If you do have side to side airflow, that's not a problem though, because the unit doesn't throw a lot of heat, so it's fine in either use case. Okay, and then one key thing on the unit is the network port connection, because for a remote spectrum analyzer like the Decimator, that's your key connection between the user interface and the unit itself. And so you can host the unit wherever you want, whether it's in your equipment room just across the way, or whether within the same building on your local area network, or whether it's on a wide area network for one of your gateways that's located in an unmanned location, or whether it's also halfway around the world somewhere else. You can still get to it all through the user interface. The other form factor that we provide with the D4 is the PCIe card. You can see that on the bottom left-hand side of your screen. The PCIe card form factor is useful for people who want to integrate within a server or just a PC that they've got. It's very simple to hook it up there. With the D4, you'll also need to hook up an extra power connector similar to most modern video cards to power it. Just the way it works within the modern computer platforms facilitates the use of that extra cable, and we provide that for you if you need it. People also use the PCIe card form factor within their own enclosures. If you're trying to integrate with some of your other devices and you have a box all ready to put it in, just using a standard ATX power supply, you can power the card within your own unit and provide spectrum analyzer capability within there. Okay, so now we'll talk a little bit more about the non-hardware aspects. We've tried really hard to make it basically backward compatible, but better than the D3, and so it includes all of the familiar features of the D3 in there. So it won't be really any surprises when we start looking at all the details of the features, that all the features are there that you expect plus more. One aspect that we're really excited about is the new user interface. It was designed from the ground up by our user interface team, and I have to give them a shout out that I think they did a great job. It's got a really modern look and feel. And one key aspect in there is that it gets away from the Java app that we used in the previous generation. When we initially designed the D3, Java applets were the common way to provide a rich user experience for somebody within the browser. But unfortunately, over time, due to security considerations, most of the browsers have made that not possible anymore. We got around that in the previous generation by providing standalone applications that could be run by users, and we provided those for Linux and for the Mac OS and for Windows, of course. But it's certainly more convenient to run in the browser. So the D4 was built with all the modern web technologies that are current right now and should be future-proof moving forward. So we won't have that same sort of issue with the D4. And the really cool thing about the HTML5 user interface is it's the most basic and commonly supported functionality in browsers. So it works on all kinds of devices, and that includes even things like tablets and smartphones. I know when I was preparing for the webinar, I pulled up the user interface on my iPhone, and it works, which is pretty cool. That if you do need to look up something and you're away from work, which is so common nowadays in the COVID times, no matter where you are on your smartphone, you can look up a spectrum and do some signal monitoring, even wherever you happen to be and at your own convenience. Having said that, I like it better on a tablet. I stole my son's tablet as well and was playing around with it a bit there to check it out. And for a guy like me with old eyes and fat fingers, a tablet's a better user experience than a smartphone. And although it does work fine there. And of course, it works on your standard desktop PCs on big monitors as well as laptops. A couple other things I wanted to emphasize just before we get further into the demo. We expanded the frequency range up to 6.5 gigahertz. At the low end, we're still at almost DC at 5 megahertz. So a wider frequency range, and that's really helpful for people who have C-band within their teleports and gateways. We support both the receive and the transmit C-band ranges, so you don't need an extra frequency converter if you can get your signal feed straight into the Decimator. So people with those types of signals within their facilities can incorporate them very easily, and it's really helpful when you don't have to have that extra frequency converter. One other quick point on the instantaneous bandwidth, we expanded it to 260 megahertz. This is primarily useful for people who are using the IQ samples, which is not so common, as most people use it in the frequency domain. But for those of you who are using the IQ samples, provides a wider signal bandwidth. So if you plan to do some external signal processing on the data captured by the Decimator, that allows you to look at wider bandwidth signals. Then another key aspect that we focused on for the D4 development was security. You know, since we last did the D3, definitely network security has become more and more prominent in everyone's minds, and has really become a requirement in everybody's network infrastructure and supported by their IT departments. So we put a lot of emphasis in this, and you'll see later that we've added in user authentication as well as over the wire, because it's a remote device. We use the encryption there for HTTPS through the web server that serves up the web page. So everything's encrypted, nothing can be snooped on or spied on. It uses all the standard latest security networking protocols in order to make that happen. Okay, I'll just flip slides here. Okay, so up to this point, we kind of talked mostly about the spectrum analysis. Another thing we're excited about is the new signal analyzer capabilities within D4. So these are some things we've never had before, and we added them into D4, and this is part of the baseline product, is to have some extra signal analysis capabilities. Specifically, it allows a deeper dive into DVB-S, S2, and S2X signals, and provides a constellation display, as well as the signal to noise ratio measured by the unit for the signal type. So this allows you a deeper inspection, a deeper dive into the signal. You can see whether any of the constellation points, if you're familiar with that, are fuzzy at all. And so we have a whole new screen that allows you to dive into that if you have a signal that is supported by the chipset on board the unit. It's implemented using a third-party chipset with a wide range of mod cods that are commonly used within satellite signals. So if your signal type is supported in there, you can do a much deeper inspection into the signal using the signal analyzer component. Another new feature that we're shown in the bottom right-hand corner of the screen is the waterfall display. You might be familiar with these from other spectrum analyzers, but we find it's a very graphical, intuitive way to look at the signal, and shows the signal over time as well as over frequency and with the intensity. And it's quite easy to spot transients in there visually as the waterfall is going down the screen. And so you can really see those transient interference signals or dropouts that might occur due to some other problems within your facility. And you can see those visually very easily with the waterfall display. Of course, included are some of the features that were popular in the past, the cross-pol isolation that allows you to look at the lineup of the signal and compare two signal feeds to see the cross-pol isolation, and allows an installer or a technician, if they're setting up the antenna to start with, or tweaking the feed horn, you can see as the cross-pol isolation changes in real time and peak that up and optimize it. One of the most common features that's utilized is the carrier monitoring, and that's done in the same manner as it was done in the D3. It allows an automated approach to keeping an eye on your carriers, setting up thresholds for the band power or EIRP that is being monitored on the carrier, and alerting people within your operations center via Snmp traps or via emails when anything goes outside of tolerance. So it allows the system to kind of run in an automated fashion and unattended while you go about doing other things, and you just get alerts if anything goes wrong. And so then you only need to pay attention to it when you need to do something. And just in general, overall, the unit includes a faster processing engine, improves the overall speed, although I thought the D3 was also pretty snappy. And we do we do encourage people that if they have special applications, there is extra horsepower for extra processing under the hood. If you have specialized applications that might have special signal types or special needs to contact us, so we can always come to some arrangement to implement some specialized features for particular applications. Okay, those are the things I wanted to go through in terms of the signal analyzer and features. Those are what I've described up to this point are all things that are built right into the Decimator. So if you buy a basic Decimator, you get all those features. We also have a couple add-on features that I'll just go through very briefly here. The first one's Spectator. It is very similar to D3's Carrier Watch, if you're familiar with that. And what it allows is a tiled display of up to 100 carriers at once, shows the spectrum, and as they're measured by the carrier monitoring feature, you can see the blue box goes around in a round robin fashion. It goes around the carriers. It allows you to see what's being measured. If the status changes, they turn from red to green or vice versa. Very quick visual snapshot of what's going on with all of your spectra or carriers that you're monitoring. And it's really convenient if you've got a network operations center or control room to throw up this tile display. You can see at a very, very quick glance, what's good, what's bad, and what you need to take any action on within your facilities in your locations around the world. What we've also added for D4 is the Detector feature, and it's very similar to Spectator, but it's based on the Constellation Displays. So you have that same sort of tiled viewpoint on multiple carriers, but for the Constellation versus the Spectrum. And if you have actually both of those features, it'll integrate actually within the same tile if you prefer both the Constellation and the Spectrum. So it's a really, really, really fast visual way to inspect the carriers. There's a whole bunch of other features within these two tools as well to look at the historical views. You can see the trends of the carriers over time, walk through that. You can play back to spot anomalies. You can play back through periods of time to see actually what was measured over time in an accelerated fashion to really dig into where problems are occurring and how to fix them. Okay, now we'll move on to the next stage of the webinar. I'll just have to click over to another screen here into the web browser, and we'll take a look at a live demo of the user interface. Okay. Shown on the screen now is the user interface. I'll just hit refresh on it. Just give me 1 second here. Okay, so one of the first things you notice is, oh, that's different if you're familiar with D3, as many of you are, a login prompt. As I mentioned earlier, we focused on security, so we added in logging capabilities because people wanted to be able to control access to the units on their network. And so we've added in that capability, and there's administrator features that allow users to be added and passwords to be changed as that can all be controlled in a sort of the way you'd expect. You can also turn off that feature if you want it like the older fashion where it comes up without a login prompt. The unit can also be configured in that way, that there's not a login prompt built in. So it's really open to the way you want to do things. By default, we ship it in this secure mode. So the comes with a login prompt and a default password. Of course, we recommend that you change the administrator password right away so that you can have it secure within your facility. And this is the new user interface. You can see it's got a modern vibe to it. It's got a really good look and feel, and has been changed here over time, built from the ground up. The initial screen, of course, has the information laid out in what we figure is a logical format. We've got the key parameters right there on the screen so that you can take a look at those. If you look in the top left-hand side of the screen, you've got the reference level and the start frequency. In the top right-hand side of the display grid, the number of averages and the stop frequency. And on the top center, the span of interest as well as the center frequency. On the bottom middle, you can see the particular switch port. The unit we're looking at right here is an 8-port unit. I've really only got a signal fed into one particular port, so that's what we'll examine as we go through the demo. But of course, you can have up to 8 signal feeds connected to it. I've got a signal generator that's got 4 carriers on that particular signal feed. So we'll see that a little bit more details of that as we go along. And on the right-hand side is where all the controls come in. We've got the sort of a modern-looking toolbar there that's got icons with the labels. If you're more screen real estate compressed, you can collapse those so you just have the icons. Then, of course, you need to learn, which one's the frequency and which is the span if you don't have them memorized. So for initially, most people will use them in this fashion where you have both the icon and the words as well, just to help guide you. Okay, so then past that, looks like a spectrum analyzer, which is not surprising, and the core features are there in terms of capturing the spectrum. We'll just walk through some of the features and go through those in short order, just to see the various capabilities of the unit. On the frequency side of things, we've got the center frequency setting. Right now I'm set to 1550 megahertz. As I mentioned earlier, the full frequency range is from 5 megahertz up to 6.5 gigahertz. You can also control the start and stop frequency if you prefer to do it that way rather than using a center frequency and a span. And so you can widen it out by modifying the start frequency. You can see here that I'm starting to cut into another carrier that I had adjacent to this one. So it's interesting as you expand the frequency, what you see in terms of your overall spectrum. The user interface also supports things like drag and drop, so you can move things around rather than by using the controls from the buttons toolbar. You can also use your mouse to drag and drop both the amplitude as well as the frequency. So it's a convenient way to do that. So if you see that carrier that's right next to it, you can drag it over and look at that one in more detail. Just hit preset to go back to where we started. Also, you can configure frequency lines. If there are particular frequency points of interest, they can be defined and put on the grid. So you can see here, I'll set up one line here with this particular bluish purple color. And you can set up a second line as well. You can control the color, so if you're someone who prefers a more stronger purple, you can do that and show that one as well. And that's useful if you're trying to plot out the extents of the carrier frequency-wise. You can put it to figure out roughly where the 3 dB bandwidth is in from a manual way, or if there was a particular item of interest on the plot, if there was a particular interferer, you could align the line with that and generate some reports from that. We'll see later how you can dump out the contents and take a closer look at that. Okay, I'll just remove those lines with a quick preset. The span, you can set how wide of a frequency range you're looking at. You can go out a little bit further. You can go out a lot farther if you want, and start to see more carriers. It's fairly easy to change that. You can look at the whole frequency span, although I have to admit probably most people, the full 6.5 gigahertz isn't, you're more interested in zooming in on particular locations within the frequency range. And there's a few quick spans that, if you're interested in 50 megahertz, you can use the quick settings to just quickly jump to different ranges. Also have amplitude controls if you want control of the y-axis of the analyzer. Most people will run in an automatic mode. The unit includes a power detector within it, so it tries to set it up so it looks good on the screen to start with for the particular range of interest. When you're in auto mode, it utilizes that to try and set the reference level so it's appropriate. and kind of maximizes your dynamic range. If you want tighter controls on that, for example, you can turn that off and control it all manually. If you instead wanted to use something, say at -20 and maybe 5 dB per division, it allows you to zoom in a little bit more and take a look at the carrier either zoomed in or zoomed out. So you have the flexibility there to use it either in the automatic mode or in a more controlled fashion. Either way is available to you. And there's also attenuators inside the unit to control the dynamic range. Again, that's something that most people will leave in an automatic format, but if you do want to control the manual attenuation, that's also possible. It depends if you're doing some complex measurements of signals and you really want tight control on all your parameters, that's available. Although most people, like I say, if you're just looking at a quick snapshot of a carrier, the automatic settings are sufficient. Similar to the the frequency lines, you can also set power lines. So these are on the amplitude. So if I show this line, then you can see, I'll just move it out of the way. You can see that one set at -48. I mean, you could try to move it up wherever you want and set it to a different value. There's again two reference lines that can be utilized on the screen. You can change the color for yellow, and if you're trying to gauge the noise floor versus where the carrier level is, there's some automated functions to do that we'll see shortly, but you can also control that all manually if you want also. I'll just shut those off so that they're not exposed while we look at some of the other features. And we also have some that happen automatically here if you want a maximum reference line. So this will show the maximum excursion of the signal in amplitude. You can see it bounce around as there's a little bit of noise on the signal. It bounces around for a while. You can see if that's for max. You can do the same thing on the min side and add a min reference line. I always like changing the colors just so that it differentiates them. And you can see that those move around as you're looking at the max and the min. Probably the max is more useful in general. Min would be more as if you were just looking at signal only, not the noise, and you wanted to see how low it was getting or if it was dropping out at all. I'll just shut those off for now. Yeah, and then we can start looking at some of the resolution. So you can see here the signal looks good for a quick glance, but sometimes you want a more average signal, more smooth signal. Looks less jaggedy, but of course it takes a little bit longer to measure. So it's always a trade-off in terms of speed and accuracy. So the full controls are available to you, but if you want to do a finer resolution bandwidth, that can be done sort of in a traditional way with the res bandwidth ratio like the D3 used, or else you can use set an explicit RBW as well. You can turn on more averages to add more smoothing to the signal, and you can see that the noise variation really goes away on it. There's also a video bandwidth mode to emulate the video bandwidth that's common on older analog spectrum analyzers. With the FFT-based analyzer, it's done sort of more in a digital fashion, but there's an emulation of a video bandwidth as well. Okay, and to this point, we've been running in continuous capture mode, which is a pretty common way to do it. If you do want to do more in terms of snapshots, there's a single capture mode, and of course then you can just hit restart and grab specific traces at times you're interested. There's some more detailed features in terms of the FFT windows, and if you're measuring a very specific kind of signal, there can be a few trade-offs if you're a signal processing expert in terms of the windows that are applied to the FFTs. So we do make those available for selection. In general, Blackman-Harris is a good it's a good compromise and pretty useful for most signal types, including noise type signals, modulated signals, CW signals. But if you do want to get into some of the details of the particular measurements, you can choose a different type of window, which would be even better for particular types of signals. So leave those ones to you, and a little bit of study into DSP if you're interested. There's also different detector types that are available within the unit, both the peak and the normal. The normal is an RMMS averaged sort of approach, which is what you normally want to use, but you can use peak if you're looking more for a noise type signal. I'll just go back to continuous mode, and then this is the normal hold. There's also a max hold mode. You can see an extra line pop in here that's showing the maximum side of the signal, so that's particularly useful if you're looking for maybe the signal level jumping higher. You'd see if you left this running over time, that pinkish line go up even higher if there was let's say an interferer in the space or something like that. And similarly, there's a min hold that goes on the lower side. And so in that case, you're looking for dropouts. And so again, you can put that extra line up on the screen and monitor it over time. If you let it sit for an hour, you can see those sorts of effects that are happening within your carriers. And the one I prefer is the min max. So it gives you the best of both of those worlds. It shows you if the power level goes up too high or if it drops out too low. So it's a very useful display to zoom in on that carrier and take a look at any minimum or maximum excursions over time. Shut that off. There's also a system. This is a place where you actually change the switch port you're looking at. You can see I've got it set to switch port 1, which is the one where I mentioned that I had those carrier signals being fed in. But if you look at one of the other ports, you can look at port 2. But of course, it's just dropped down off the screen because it's just noise-like. So that's not such an interesting one to look at. But if I go back to the other switch port, then we're back to the signals again. Our user interface people put in a couple different color schemes. The one that's most commonly used is the black background, or sort of a dark mode, as most things like iPhones have gone to. But also there is a white background that's available. This is particularly useful if you're trying to print something, and if you're using something like an inkjet printer. If you have a black background, you're suddenly using a whole bunch of ink or toner in a laser printer. So there is both different types of color schemes available, easy enough to click through those. Some details in terms of the connection timeout and resets, a little bit of status that shows some of the details of the unit, presents hardware part revisions, things like that, the software version, and status information on the temperatures within the unit and the voltages. And of course, you're looking for all green here, and hopefully that's what you normally see. There's an error log, again, with a quick summary check mark, no errors, which is always good. And there's a help information as well that pulls up the PDF of the user manual. So it has all the information about all these features that I'm going through here today in even more detail. You can also save states. This is similar to other spectrum analyzers as well. As you can save a state, if you want to say, okay, well, I like looking at this carrier, I'm going to capture this state that I've got right now set up on switch port 1, centered at roughly 1550 megahertz. Capture that state, and I can even name it if I like. I'll call it webinar. And then if I did if changes, if all of a sudden I wanted to move over to another frequency, look at a different carrier, you can do all sorts of different things in there, and then say, oh, but I really wanted to go back to look at what I had been looking at a minute ago. Easy way to flip back and forth and maintain your settings. Up to 10 different states can be stored, so you can store several different use cases. In the trace mode, you can capture a specific trace. So, if you're interested in capturing a moment in time effectively, if I captured this, you can sort of see in the background a red trace. So that's a reference trace. You can store that and export that to CSV if you want to include that in, say, an Excel spreadsheet or something like that. You can do that easily enough, and also store it to recall it later to use as a reference trace if it's kind of in a golden state at the moment and you want to be able to compare it, say a month from now. You can then retrieve that trace that was captured, plot it against what you're seeing now, and see if there's really any differences. The marker features are handy. There's several different types of markers. You can see that once you turn on one of the markers, you can see here with the one with the plus is the marker shown here, and you have control over the shape if you prefer to use an X versus a plus sign or a diamond. You can set those up for different types of markers. Of course, you can also set up the different colors. The red shows up reasonably well on the green, so it's something that we used as a default color for the first marker. It's most useful with the 10 markers if you turn them all to different colors. And there's different types of markers as well. What we're showing right here is a normal marker. Up here on the left-hand top side of the screen, you see a marker table, and it's saying that marker number 1 is at frequency 1551.1 megahertz, and its associated power value. And of course, with the markers too, you can drag and drop them with the mouse, which is handy. A commonly used marker style is the delta marker. So this is quite useful when you're trying to look at a particular signal. You can move it around sort of and check out the 3 dB bandwidth power, because it'll also compute the band power for the delta markers. So you can see here it's about -16 dBm for the overall power within the signal, as well as the different power points relative to one another and the frequency difference between the points in terms of the overall display. So the delta markers are really powerful when you're trying to dig deeper into a signal. I'll just shut those off though before we move along to a few other features here. Just very quickly, there's the report features. You can export, what you're seeing on the screen here to HTML, so then you can send it off to somebody, show it to somebody. If you want the details in terms of the values within the trace, so it's the X and Y values, and wanted to do further processing on those, you can also export those to comma separated value files, and those types of files can be routinely used by Excel, MATLAB, any sort of third-party package you want to use to take either process them or plot them even in a different way, as you could start to overlay different types of plots if you captured several different traces. Another feature that is very powerful that I mentioned to you in the introductory slides is the cross-poll feature. What it allows you to do is compare two signals. For my webinar here today, I don't have a great second signal. Normally the second signal would be sort of a lower level version of the first. So the numbers here are not so realistic because one's an actual signal and one's a noise-like signal. But you can see that very quickly it computes the cross-poll isolation between the two signals and shows it up in the left-hand corner of the screen. So if you were doing one of those lineups on a carrier, initial commissioning, or handling your antenna out there in the field, you can use this to peak it up and to optimize the cross-poll isolation for the signal. And as you're tuning it, you'd see the values go up and down and the signal levels go up and down as it basically switches back and forth between the two signal feeds on the two ports, and shows them both on the screen in a handy way, and allows you to do a quick computation and plot, shows that for you right away. A really easy to use feature. Turn that off, and before we get to the carrier monitoring, I just wanted to flip over to a couple of the other features of the unit. You can see something that's a bit different on the D4 is that there's this apps bar, as we call it, And you can see that you have the normal spectrum display as shown here. You also have things like this is where you access the waterfall display as well. So you can see here the signal intensity. What this is showing on the x-axis is the frequency, and on the y-axis, in this case, it's time. So you can kind of see it going down in time, and you've got the indications of the actual time range on the left axis. The amplitude of the signal is shown by the intensity or the color. You can see the legend at the top of the screen that varies from 0 dBm at purple down to -100 in black. That range is configurable as well in terms of how the colors are shown. Because most of the signal is kind of flat, this is the yellow part here is the top part of the signal. The blue is the noise, and in the transition zones you can see a bit of green. Now, if an interferer had popped in there and was sort of in the center of the screen, you'd see the intensity go up to maybe probably something in the red zone, and you'd be able to spot that visually very easily. So that's the real power in the waterfall display. And it's easy enough to flip back and forth between the two modes through the apps bar. You can see as you go back into the waterfall, it resets itself and shows you a refreshed display. It's even more interesting if you if we widened out the span here and we look at more of the carriers, so you can see that you've got the 4 kind of carriers shifted to the left-hand side. So we should be able to see the intensities kind of aligned with that on the waterfall display. And you see that here that, you can see the intensities of those signals, and most of it you see is the green noise. I'd have to fine tune the measurement a little bit to increase the resolution bandwidth to drop the noise floor so it's a little bit lower like it was in the narrower span, and then it would be back down in the blue level like we saw with the other signal. Okay, the other thing I wanted to get to here is the signal analyzer. And if we take a quick look there, it's a whole new screen. It's new for D4, and to show the constellations, we first of all have to feed a little bit of information into it so it knows enough about the carrier type to be able to lock onto it. So we'll look at the signal that's at 1500 megahertz. I've got it set up in the signal generator, so it's a DVB-S2 signal. You can see here there's the different types of modulation standards. There's DVB-S, DVB-S2, DVB-S2X, and the various mod codes that are associated with those types of signals. So if I drop down the list, you can see it's a fairly extensive set of signals up to the 32 APSK formats. The particular signal type I've got here is a 16 APSK signal. So I'll enter that in. The signal rate's 15. You don't have to quite be exact, but you need to be close enough so that the tuner can lock onto it. And then you just hit play on that, and you start to see the signal showing up on the screen. So you can see there the 16 APSK signal on the left-hand side of the screen with the constellation. And this matches with the way it's supposed to look because you have sort of the 4 central points and the other 12 points around the rest of the ring, and gives you the constellation display. The signal is pretty clean. It'd be more similar to a transmit type of signal where the signal to noise ratio is very good. If you look at the top part of the screen, you can see that the DMOD is locked to it and the SNR is at 33 dB, which is quite good. You can see that we're not connected to a 10 megahertz reference source here, so we have a little bit of frequency offset as the tuner locked onto it. You can see that the actual frequency of the signal is a little off from 1500 megahertz, and the frequency offset is off by about 425 kilohertz. And there's also a bit of a symbol rate error as well. And depending on whether it's a DVB-S2 or DVB-S or DVB-S2X signal, you'll also get some extra metrics as well for the BCH blocks. And this is for the error correction that's ongoing in there. So you can see it's doing a pretty good job out of lots of blocks. It didn't need to correct any. Found a few bad blocks. I think that was probably just in the original acquisition of the signal before it got into sort of the meat of constantly processing it. You also have a snapshot of the spectrum as you're looking at the constellation, which is kind of useful, so you can see both all in one. And on the bottom right, there's some capabilities to have trend plots. So what's being shown right here is the SNR of the signal. It's pretty flat is what it comes down to. It's not a very interesting trend, which is maybe good. Interesting it can be good. It can be not so good if it's jumping all over the place and might show a problem with your signal source. But in my contrived webinar situation here with the signal generator, it's pretty stable. So you can see it's a very flat line. And similar to the SNR, if you want more plots available, you can just click on them at the top, and then you can kind of see that the frequency offset is wandering around a little bit, and symbol rate error. You can add multiple plots here to do some more extensive analysis. So if you leave this up and running for a while longer, you start to see some of the trend information over time. It can really teach you a lot about what's happening within your facility, and how the signal levels are varying or not. And it helps you understand better what's going on, and you can then decide whether you need to take any actions about it. Okay, so I'll just shut that off and just flip back to the main application. Yeah, so it's back here, of course I mentioned that we have multiple carriers that we have within set up within the unit. So if I take a quick scan here, you can see the 4 different carriers. On the carrier monitoring side, we can monitor those 4 carriers and check them out and make sure that they're operating okay, and send those alerts off to people either via email or Snmp. So it requires a little bit of initial setup. It's not hard, but it does take a little bit of time. So rather than go through it sort of here live in the webinar, I had set up a little bit of stuff beforehand in a project file. So this is a way that you can kind of set things up and just recall them whenever you want. Once you have a kind of a golden state that you like, you can save it to a project file and then reopen it as necessary. So as you reopen your application. So I just created a webinar version, and if I look at the carrier monitoring, I'd set up different the settings for the 4 carriers, basically the center frequencies and the spans. You go through and you set up each of those on the unit, call it a carrier, and then add it to the carrier monitoring. I've set those up now, and you can see on the left-hand side of the screen the control toolbar for the carrier monitoring application. And then when you want to start it, you just hit the play button. It cycles through the carriers, and so you can see the green and red gumballs, and those kind of indicate the alarm status of the carriers, and just cycles through them one after another. And you can kind of see over time, again, similar to the signal analyzer that we were looking at, it's got the trend plots shown at the top of the screen. Again, these are very flat, so they're not so interesting in terms of the actual trend, but over a real signal over the course of a day, you would start to see some interesting characteristics present themselves. And it just goes through the gumballs there, and just continually cycles through, and will send out that Snmp or email as you've configured it for your carrier monitoring if something should happen, if there's a transition in the state. I don't at the moment have a way to change the signal level to cause a instantaneous dropout or anything that would be that demonstrate that, but that's what will happen in practice, is you'll get those alert notifications. Yeah, so then I just wanted to quickly flip over as we're starting to get through the time of our webinar to look at Spectator and Detector. What we've seen so far are all built-in core features. On the apps bar here, if you don't have a license for the Spectator Detector, they'll show up as a grayed out feature. But here, I've got full capabilities of the unit, so you can quickly see here that the tiled display really comes up very quickly, and by default kind of shows all the carriers. You can in the top decide to just show the alarmed carriers, so I just see the one carrier. So if you wanted to kind of do a quick zoomed in display, but on the user defined portion, you can see the different tiles. You can kind of see a blue box if you pick up on that and see it remotely. You can see the blue box moving along as it gets measured and gets updated. You can see the blue box update and show you the changes. There's a bunch of features in here to look back at historic trends and inspect the traces at those points in time, because they're all stored within a little database within your PC that you can then access later. So that's a handy feature. I won't go into it in any detail here today. We'll probably have a future webinar that really takes a much deeper dive into that, the carrier monitoring and the Spectator and Detector add-ons, and that'll be helpful for people who are interested in the details, as I don't really have time to get there today to try and touch on everything. So yeah, so if I take a quick look back here, Detector is similar, except it's for the constellations. Right now, that carrier monitoring, I noticed that I don't have anything set up in terms of a constellation display monitor. So I'll just stop the carrier monitoring for a second. And the third carrier is the one that we were just looking on, the signal analyzer screen. So if I edit the settings on that and turn on the SNR analysis and just make sure that my settings are okay for it, which they look all right. Then I believe I should start getting the Constellation displays integrated as well into the Spectator Detector display. Let me just flip over there to confirm that. Yeah, so you can see similar sort of Constellation displays we were looking on at the signal analyzer screen. And again, in a tiled display. And here, like I was mentioning earlier in the slide deck, is that if you have both Spectator and Detector, you can look at both, and you can kind of do some mix or matching. If you're only interested in the spectrum, if you're only interested in the constellation, you can toggle back and forth and take a deeper dive into the signal and just display what you're interested in. Okay, we're almost through the features here today. I just wanted to quickly show you the config screen. This is just for when you initially get the unit. You have to do a little bit of setup if you want to use any settings that are different than the ones that come configured out of the box. Probably the key thing that you will want to change for your facility is the IP addresses. It comes with a default static IP, but you'll want to change it to something that is appropriate for your network. You can add in routes as well. Also, IPv6 is supported for facilities that have moved to the more to the IPv6 format rather than IPv4. I'd mentioned that there's user accounts that the administrator can add new users, so we could create one that's specific for a person. And there's different capabilities that you can add. We call them operator and viewer. So if I was adding a particular webinar user, I specify how much capability they have. If you want to restrict what they can do, you can give them less capabilities. I won't add one at the moment. Just quickly, there's some extra features in terms of calibration. If you want to add calibration files for basically any sort of gain versus frequency response on a particular port, for each port you can do that. That gets incorporated into the calculations that are shown on the trace on the screen. You can name the ports. This is really useful. I'd name the one demo port for today, but if you had different satellites that you're connected to or different satellites and polarization combinations, you can list them here, and it makes it, since it's shown on that main screen of the Decimator, if you recall, sort of in the bottom middle portion, it's really convenient ways that you know exactly what you're looking at immediately. Certificates are more of an advanced feature, but if you want ultimate security and control your own security certificates, that can be done. The user manual goes into some depth into how these files need to be created, and then you can create them custom for your own installation, and then control the security entirely that's accessed within the unit. Licensing, remote access, like I said, was built for security. So by default, it comes in a secure mode where the different sockets are turned off other than the main socket, but you can turn those on. One thing I didn't mention is that the D4 includes an API that's the same as D3. We term it the legacy API socket. And so that allows you, if you have it integrated into some of your programs or your network management systems, should be able to use the same driver for D4 versus D3. As always, we'd recommend you do some checkout of that just to confirm it. But the intention there was that the command messages that are sent over the socket are the same. And similar to D3, we've got an Snmp port that provides some basic status information, and that also can be turned off or on depending on what your IT department wants. You can update the firmware over time. We provide firmware updates as we add new features or new capabilities or bug fixes on our SFTP site. So when you download one of the newer versions of the firmware, this is the place where you can update that. You can also do a reset on the unit from here as well. That is the D4 in a nutshell, a really fast tour of everything. That's the key things that I wanted to touch on in the live demo here today. At this point, I'll just get out of the live demo portion and go back to the slideshow. And Jim, I'll turn it back to you at this time.
Okay, thank you very much, Peter. It was a very informative presentation. Much appreciated. Throughout the session, we've received some questions. So now we'll move on to the Q&A portion of the webinar. I'll read the question and Peter will provide answers. I can say, just given to time constraints today, we likely will not get to all of the questions. But having said that, some of them were covered in the webinar, but we will, you can either submit them to us via email again. You will have our contact information, and then as well we can get back to you on our own initiative. So first question I have here is how many seconds does it take to build up a proper Constellation display? Also for the Spectator option, which is the similar to the carrier watch in D3.
Yes, so to build up a Constellation display, you know, the Constellation points kind of come in from the chipset. You get basically 1,000 points a second into that Constellation display, so it fills in pretty quickly. The ones that we had shown here in the demo were pretty tight Constellation. If you had more of a noisy Constellation where the signal to noise ratio was maybe 812 dB, you'd kind of see the noise parts kind of trickle in or display. And so, you're getting kind of an update every 1 to 3 seconds on the signal analyzer in terms of the trace points that are shown on the display. There's a control there for how many points you want to see. So, the older points kind of age out, and then the newer points come in play. So you have some control over that, which I didn't actually touch on in the demo, to show how many points that you want to display. And that allows you to kind of see more of the recent effects and slowly fade out the longer term effects.
Thank you, Peter. Next question. Can you record a week or two? I'm checking for 5G interference.
Yeah, so you can with the carrier monitoring. Like I said, mentioned, there's a database. There's kind of two ways you can do the carrier monitoring. One is just with in-browser storage, which is more for short term. But if you're interested in the case where you're describing in the question, you'll want to set up the database. And the manual has description on how to do that. You can store longer term storage, view that either offline or within the Spectator application, and you'd be able to do that.
Okay, good, thanks. Next question is the D3 going EOL, end of life?
We did announce an end of life on the D3 last fall, and so sorry if you didn't get a notification on that. We tried to send that out to everybody, but we continue to support it and provide warranty if necessary. We've stocked up on some extra parts. So some of the parts have gotten difficult to procure over time, which is why we decided to end of life it. And plus we're also pretty excited about the D4 version, which we think has all those capabilities of the D3 and more, and at basically the same price point. So we definitely feel that the D4 is a better option for people moving forward, but we'll continue to support the D3 and provide repairs for the foreseeable future. Minimum of 5 years, if not longer, as long as we can find ways to find parts, we'll continue to support it.
Thank you. Next question says, our company has many D3s in the field. We love the new features and functions of the D4, but I must ask, how long will you support the hardware and software of the D3?
Yeah, I just kind of touched on that. The hardware, probably, as long as we can. For example, with the D1 was, I think, about 2008, and the D2 was maybe 2012 or so. And we continue to help out users with those units today. If something happens, like a fan fails in the chassis, we're often able to repair those units for people. So really, we'll support it for the foreseeable future on the hardware side. If it came down to a point where sometimes it's uneconomical, depending on the particular failure mode. But our general intent is to continue to support it in the future. On the software side, we won't plan to have any particular new software updates to the D3, unless somebody spots a bug that we feel is necessary to fix. We do that, but otherwise we're not rolling out new features for the D3 at this point.
Okay, and this will likely be the last question because I know we're running out of time here. But there is as mentioned, we will get back to you on any unanswered questions that are submitted. And so a last question here is, why is the D4 75 ohm accepting a different frequency range than the 50 ohm model?
Yeah, so the 75 ohm uses the F-type connectors, which in general are rated for a lower frequency range. So although inside the box, it's the same capability between 50 and 75 ohm, at the connector side of things, the RF performance of the F connectors is just poorer. So we rate the 75 ohm at 3 gigahertz due to the connectors that are involved there. And typically, people who have a plant that has the 75 ohm infrastructure are working at frequencies below that range anyways. But if you do need the higher frequency ranges of C-band, we do recommend using the SMA connectors. They're rated for a much higher frequency range and are supported by the unit up to 6.5 gigahertz.
Okay, I'm going to squeeze in one more here before we go. How many users simultaneous? How many users can be on the at the same time?
Yeah, up to 10. One of the kind of the neat features of the Decimator is it allows independent sessions. So people, I can access it through a web browser, Jim can access it through a web browser, and we both have our own independent sessions. So under the hood, the Decimator controls all that and switches the switches if it needs to, changes the settings. But I get my own user experience, and Jim gets his. And we support up to 10 simultaneous users in the Decimator.
Okay, thank you, Peter. And that brings us to the end of our webinar today. I want to very much thank everyone for attending on behalf of Calian. And I might note this is the beginning of a series of D4 webinars we will be hosting. If you have any suggestions for future topics, you can leave them in the comments or email us directly. Again, thank you all for attending and have a great day and week. And we will sign off now.